Yeah, so we are looking at the object paradigm mismatches. So we spoke about the granularity, having finer grained classes that consist of only strings, and user and coarser grained classes like user that has an address uh, that contains an address class. Right? And we also spoke about the problem of subtypes, which also talks about associations. And when you say subtype, you also have polymorphic association involved. So let's say I pick up a billing detail, one billing detail, or at one time it could be any of the two billing details of classes possible. So how do you solve it is also depends on how you map the class inheritances. The problem, and then the problem of identity. Now, in an e-commerce system, you want to identify that you're always referring to the same item. So there are two ways that you do in Java. You have the equal to operators, which compare references, and then you have the equals operator, which uh, which means that the data contained is essentially equality by value, right? But now neither of them is used in the relational database when you say the two items are equal. So the database in our user table, you may have a username column, but that could be called the primary key. That's the identity of the database, and you have a similar username field in your property in your class. But it is quite popular to use surrogate keys, so which are unique primary keys meant for the purpose of identifying different rows to be either one or different, right? So whenever you create a table for user, you define something like user ID, which is a primary key and not null, and it's a big int, and you can have a billing details, which is also a primary key and not null, right? So each one of these values will contain system generated values. So how are you going to populate? How can the system handle this? Is something which we need to see, right? Then we also have the problem of associations, which means in Java you only have you have in relational databases you only have a one-to-one or one-to-many with a foreign key. But in case of let's say a user, you can have user dot get billing detail, or you can have billing detail dot get users. If there are several users who are the same billing details, which is possible, right? So we have concepts of one-to-one, one-to-many, many-to-one, and many-to-many. As far as many-to-many in a table is, you use a link table to go about dealing with many-to-many. And you also have the data navigation. So how do you navigate? Get an account number that you have a user, dot get account billing detail, dot get account number, right? So if you write a query, right? So you write a query that upfront you know that you need to get the account number. Then you will write a query using a left outer join between user and billing detail, and get the account number. So what if the person doesn't have an account number, right? But this requires that you know the data that you want to retrieve, right? But that may not be true uh, for objects. So because you know when you are at the user listing page, you never know that you are actually going to click one of the listings, right? Which means that you have to retrieve one record, and then from there you decide whether you want to retrieve the associations also, the graphs. So that's a problem which, if you're done in this manner, like you retrieve one object and then try to retrieve every record of associated objects, it may take it's called the n+1 problem. So that also has a solution in Hibernate, right? That's what we are going to see going forward.